welcome to our presentation, Big Data Visualization in Public Health. Just letting folks roll in here. I'm John Bowyer. I'm from the CDC's Office of Public Health, Data, and Surveillance. And I'm from the federal government, and I'm here to help. So if you find those words a little scary, I hope they'll be a little less scary by the end of this presentation. I've been working seriously on a lot of these innovations that you'll see today, very hard for the last 5 years over 5 years, with over 100 people across 6 centers and offices at the CDC. And over that time, we've ran into a lot of challenges and learned a lot of lessons. And I'm happy to share those with you guys today. This is the first time I've presented these findings publicly, and so I'm excited to do so. And when on the team, on those lessons, we're going to focus on 2 main areas: big data visualization in public health and building faster and more reliable data products. So a little disclaimer. As we begin the presentation, it's important to note the context and the scope of the information that I'm presenting today. The findings and the conclusions presented are those of myself and the contributing authors, and they don't necessarily reflect the official position of the Centers for Disease Control and Prevention. The data and examples are based on specific CDC use cases and don't necessarily constitute an endorsement of any product. So what have I been doing and our team been doing? The name of our project is CDC Data Hub. And CDC Data Hub is a one-stop shop for data at the CDC. It has over 50 unique data assets from 13 different providers. And it covers visits, labs, medications, costs, etc. And it's used by 450 users across 18 CDC offices and centers. And what do they do with that? They produce a lot of research output to help public health. We facilitated over 900 publications since 2009, contributing to 46,000 citations in scientific literature. And we've done all of this the whole 5 years on the Databricks platform. And it's been an awesome journey, and I can't think of a place I'd rather be than where I am at the CDC. And it's really fulfilling to do this work. So, presentation, objective, and agenda. So we're going to explore an accelerator methodology that we've just implemented this year in 2024 on top of the base CDC Data Hub architecture. And that accelerator methodology solves 10 specific challenges that we faced. And we'll step through those 10 challenges today and highlight how we addressed them. And we break those 10 challenges down into 2 parts. First, we'll start with people, and then we'll go into technology. And why should it matter to you guys? Well, a lot of this has to do with public health. I'm going to try to focus on the areas that apply to you, the broader non-public health audience. Data products, big data visualization in general, and use our implementation of an RSV dashboard as a specific example. And those are my bullets. So a little quick bit about me. My name's John, and I've been working on data for over 30 years. I started out in the 80s with punch cards in Fortran at UGA, and then moved on in the later 90s to work for Fortune 500 companies, modernizing mainframes and using SQL for when it was new, and new in the SQL Server sense. And then moved on to the dot-com boom and bust in the early 2000s, started working with pharmaceuticals in the early 2000s as well. Spent about 10 years at Microsoft before I spent the last 5 years at the CDC as both a contractor and a full-time employee, FTE. So I went to Georgia, and I live in Tuscaloosa, Alabama. And if you know anything about the SEC, it's a pretty hard place to find happiness for a Georgia grad. But I'm I couldn't be, there's nowhere else I'd rather be than where I'm at. And a little more about CDC Data Hub, which is the project that I'm working on. Again, today we're going to cover the 5 improvements on the left for the process people side of things, and then move on to the 5 technology sides, advancements that you see on the right. And I think we should just sort of dive right into it and get started on the people side of things. So on the people side, process modernization. So process improvement number 1, it was that the hardest part of sort of helping people with visualizations was having them find the visualizations. And so this was the number 1 challenge was in what I'm calling the engagement challenge. And you can kind of think of it as sort of dashboard drifters. If you were to be able to see this presentation and look closely at the right-hand image there, you would see that there were just a list of reports in standard Power BI format. Some of them said old, some of them said broken, and some were the production reports that our users were supposed to find. And what we needed was a site that was integrated with our intranet and was searchable, discoverable, and it also gave confidence that there wasn't intermingled in development work separated from our production work. Another lesson learned from the COVID response was that this architecture that you're seeing, while we just implemented in CDC Data Hub, it's been around for 5 years, so what was it doing? It was actually used in the COVID response to send reports to the White House and other areas. And those external customers of the CDC don't necessarily log in and look at a Power BI dashboard. So being able to produce high quality, rich PDFs, Excel on a daily basis that were in an automated way go to their emails and to their SharePoint sites with with an Excel file named with the date of the current day or week were very important during the response. And so we've also included those methods in this. So this is what we've got now. We've got a nice new intranet site, and it's got our reports embedded in it. And they have not just Power BI dashboards, but they also have Power BI report builder exports in rich formats. And so that's sort of opportunity number 1 for optimization in the process side of things. So the second process improvement number 2 is agile user stories and recipes. And so I mentioned that there were hard lessons learned. And this is probably the hardest personal lesson learned, was that I worked really hard over those first 3 or 4 years and created a 500-page SOP document on everything we should all do to solve these problems and challenges. And for anyone embarking on such an endeavor, I would just caution to not be overly optimistic about people's response to a 500-page document of any sort. It doesn't really matter the quality because they're probably not going to open it. And it's it was a little bit humbling to work that hard. Effort's not always related to success. Sometimes resilience and adaptability are more important. So the lesson that I learned from that was that we needed to change. And so we created these things called recipes, which are just really specific, targeted, step-by-step guides. And we got the idea of a recipe from the vendors. Databricks has a really good concept. They use in machine learning. But then Elation and Posit also use this concept of recipes, and they work. And so that's really rewarding, because some of the same folks that I've been sending this big document to for years, now they need to onboard a user to GitHub, or they need to CI/CD recipe, and they're liking it. And it's almost shocking sometimes. I'm like, wow, success. But it's not necessarily like a straight line journey you'll see in these things to get there. So that was process improvement number 2. So process improvement number 3 was the machine readable requirements. And this is a real challenge because the way that people typically do these are sticky notes, and then if they're adept at SQL, they'll just put the requirements right in the SQL that they write. So there's this sort of vague vortex where the requirements that we need to be in a document that's compliant don't exist in the format that a machine can understand. And if they're on a sticky note, a lot of times what they'll say is that I need a longitudinal analysis of any data source over any time for any reason by next week. And that's a good, ambitious goal, and it is good to get users' desires on paper. But what we really challenged with was creating a format that a machine can understand. And so what we've done is we've created an Excel template, the latest version of it, and it captures requirements in a grid-like form that are machine readable and human readable. And this obviously requires a little bit of training of our users, which we have to engage in. But training users on Excel to capture their ideas is still a much more efficient and beneficial process than training them on SQL and having it hard-coded. So that's that Excel, though, that is entered is uploaded into the data lake, and it does end up in Databricks, and its drives is literally, not only is it machine readable, but we do actually read it and drive our processes off of the machine readable requirements. So you're in a big data visualization talk, and so I imagine some of you guys want to see some big data visualization. So, woohoo! So thank you guys. So process improvement number 4, streamlined content dashboard interface. So what you're seeing is, again, this concept of templatized reusable work. The template that you're seeing is a starting point. They don't have to use this, but for each project, we follow a certain data structure, which I'll go over to later. And at the top of that data structure is an app. In this case, you're looking at an exploratory dashboard. And then beneath that, there's a second level subcategory. You might wonder, where's the category? This is a Power BI report that you're looking at, and the tabs down at the bottom, which you can't see, are the categories. So once the user can drill down through the app level, which is data-driven, to the subcategory, which is data-driven, they can get to what we call the view by, which is their dimension level partitions for big data visualization. And this allows them to view anything by age. I think right now, on this report, we have somewhere between 12 and 20 dimensions. And then for each of those dimensions, you can drill down further and choose one or more of the subcategories. And then you can also drill them all by time, and then the metrics are across the top. So the point of this visualization is not so much just the UX, which is admittedly pretty descriptive statistics, generically based, but to really set the basis for a data model driven, a data-driven approach to visualization. Because at the end of this, you'll see that there's 10 times improvement by the optimizations that we made. We had an initial version of this dashboard, and then we have the current version. And the current version does a lot more with a lot less resources and a lot better user experience. So this is the process improvement number 5 is, I think, a generic enough process improvement that we've probably all experienced it inside or outside of technology, which is that it's what I'm calling the phantom facts challenge, where project reports or project plans, those Gantt charts that leadership may see, may not necessarily reflect exactly the details that you see in your Jira dashboard. They're probably not necessarily created in an automated way from Jira. And if they do match, and even if they're even more correct than Jira, there's not a way to drill down into your details. So there's this sort of office document, PowerPoint leadership world of things, and then there's the Jira tactical, real world, on the ground point of things. So what we've done by that to help address this process challenge is integrate Office and Jira with an API and make it so that we have PowerPoints that allow the use and Excel documents that allow our leadership to drill down and see the results. And also, if you're in a stand-up, it's sometimes a lot more efficient to just, get the data quickly entered in, filter in Excel, and then enter in a new Jira task at the end of the stand-up. So these improvements have made, these 5 process improvements have made substantial, probably even more impact on our technology stack than our technology stack. So on to the technology stack, but I'm biased. This is still my favorite stuff. So we will get into the technology advancement number 1 now, which is that this is our common data model. So if you think of this as a pipeline factory, and we're building pipelines, this is sort of the schematic of how we build our pipeline structures. And what we had before was we had the reason that report was so slow. It was kind of a molasses report before, and we're 10 times faster now. That visualization that I showed you guys earlier was because the initial report that I began to use had 400 columns, and to add another metric, they would add columns for the combination of the metrics and the dimensions. It had 6 rows and 400 columns. So I call that the pancake stack dilemma here, where again, it was almost like my document. Sometimes you just got to revisit things and say, hey, this is not the right approach. And you need a normalized data model. And in some ways, again, it's a blessing because it forces you to rethink everything. And that's what you'll see here is our data model for visualizations. So you'll see that if you look at this, you've got the app on the right and the view by categories. And it's all data-driven and normalized. But in the middle of this is we've used a lot of common, there's so many common data models in the world. And so you might think we have the sort of rotten tomatoes of aggregator of data models. We use OMOP, we use FIPS, we use a lot of different data models, and we've sort of standardized those and harmonized those on the Databricks platform. And it's important to note that you can also put different data in the same data model. So while we may use an OMOP schema, and I'm throwing out a lot of acronyms that I'm not going to necessarily go through each one of them. You can just think of these as database standards. But we've sort of harmonized them together. I guess that's the key point into these structures that you're seeing on the screen. And the bottom structure here is for our pipeline factory. This is sort of the basement of our pipeline factory. These are the data structures that we use to drive the ETL processes. And interesting enough, those same Excel spreadsheets that we talk about machine readable requirements are used in each of these areas as well. So if a user goes to configure a new job or a new workflow or a new bronze data set, then those spreadsheets and machine readable requirements funnel into these data structures. So that's technology advancement number 1, which is our pipelines. So on to technology advancement number 2, which is our data conversion. So I'm calling this technology challenge conversion chaos, which is, and I've got we've seen this talked about a little bit even during the keynote this morning, but I actually put some visuals about how hard it is when you go to different, like I said, we have all those different vendors supplying the same EHR, electronic health record type of data. And they're all in different formats, not just physical file formats, but the structures are different. And that's super hard for our scientists, and it's super hard for the people consuming our work if we replicate the problem and give all those outputs out. So while Databricks has done a masterful job of harmonizing the data sharing process, what we're talking about here as a universal data connector is having a universal data structure and then some standard formats so that the people consuming our data get their pivots with, geography means the same thing, and it's in a standard way, and that they get the data in pivot format if that's the most appropriate way for them to receive the data. Another way that we're standardizing this data conversion is, I think, an underutilized, and I would really want to brag on the Databricks platform for this. If you guys haven't been using Databricks SQL, or if you are using Databricks SQL, I super encourage you to look at parameters. In the keynote this morning, she just did a couple brackets and she just entered text. But if you're using Databricks SQL, enter a couple brackets and choose the drop-down option and see how awesomely powerful it is to have regular users use parameterized SQL. So what we can do with this is we can have one generic SQL statement create 50 to 60 different views in an automated way, just accepting a different parameter. And the output of those 50 or 60 different views, if we have a standard long skinny code lookup table with state, name, and just code decode, when we go and pivot it, we can actually make the state star table have the name state code and state based on the parameter that comes in. And if it's gender, it says gender name and gender, because it's using those parameters to create the column names. And it's a tremendously powerful way to reduce complexity and still give people the best of both worlds in a data model. And I haven't seen enough of those features evangelized here because they've done a great job on them. And again, this is the common data model structure that I just talked about for codes and decodes. It's based on OMOP, but all of you probably have some sort of value set or lookup, whatever your name is for the same thing. So on to technology advancement number 3, data governance, expectation tracking, and tools. And if you felt a little oomph in my voice here, I guess I'm a little passionate about this one. I'm calling this the opaque oracle problem, but there's a key thing. First, you need to have machine readable requirements. They can drive your requirements, but you need to have expectations that you monitor. And those expectations need to be captured. So a manager may say they want to have a longitudinal analysis that does anything, anytime, but those aren't measurable. So we have to have the same kind of machine readable rules that we did for the requirements did for our testing. And that's part of what this slide is about. But the part that I'm most passionate about is the synthetic data part of it. Because I think the biggest piece of ethical AI is that if somebody tells you a secret, you shouldn't share it. And the best way of not sharing secrets is synthetic data in my mind. That doesn't mean that we never test with real data, but we should be able to test with synthetic data. And if there's I'm sure no one in this room has ever heard, you can't see my data because it's private or secure. But I've heard that before. And if we all use synthetic data or we have some sort of mandate for that sort of thing, then day one, we can share our data both internally and externally. And what's now a private problem for me at the CDC can be a public problem for you guys as citizens because the data is available on Kaggle for you to start helping solve public health problems with synthetic data. So maybe I'm putting too high expectations on you as an audience, but those are the kind of dreams I have for us, is that we'll start being able to capture these requirements better and then share them with you and then help engage the citizens. to help us solve these public health challenges. So there's been a lot of talk about data products, and everybody has their own definition, and this is my definition since I'm on stage. So for me, the challenge that the data product is solving is the metadata mystery. And so a lot of times, if you think of the pipelines that we talked about as sort of the structure and the data as the gas, then the data product is sort of the packaging. This is what the customer sees, and this is how they engage with it. It's like they said in the keynote or somewhere that it's a product life cycle where you have a start date and an end date of your product, and you have some governance rules around it. And Unity Catalog solves some of this, but it doesn't prescriptively give you rules. And what you'll see consistently throughout this expectation is, or this presentation, is that we're trying to sort of raise the bar in terms of structure and guidance that we provide folks. So for us, a data product means that it's a database or a data source, and then those data sources can have multiple data sets or tables in a schema, and then they can map to an individual data set, and they're packaged in a way that is meaningful to our users. And they can, so an example to make this a little more real world is that these analytical pivots that we're talking about are data products. They're part of the data product. And so for us, goal doesn't mean putting it in a flat table and have the user create their own metrics and metric definitions. We're actually defining what the metric definitions mean, what the dimension definitions mean in our data products. So we're about done. So on the 5 of 5 standardized data product lifecycle, technology advancement number 5, and this one I'm calling the reinvention rocket. And so a lot of times what you'll find on these projects is that you recreate things from scratch, or at least that's what we did. And you don't necessarily have a consistent ETL process. And so just like we talked about the pipelines for the structure and the gas for the data, what you can think about this standardized product lifecycle as the pump to pump the gas through the pipelines in our factory framework. And the key components are down here at the bottom. We call it the ideas framework. And so that means it starts with ingress or ingestion. The data comes in from the internet, and it goes to a data store, so in a raw data storage. And then it ends up on the far right with the S on the serving and storytelling. And the parts in the middle will go through. So it comes into ingress, it goes into our data lake storage. Then we do a data load, and it goes into our bronze table. And these are actual function names in the code. There's 50,000 lines of code to drive all of this magic we've been talking about. And then it goes into this process data load section. Then it goes into the enrichment stage. So once it's into a raw bronze table, we can add geocoding, we can extend it and extend the data with other additional elements. Then we can do our analysis phase, which is all the fancy pivoting and things that we talked about earlier. And then we can do the final phase, which is our storytelling phase. So that's the end of our top 10 list. So again, we've made significant strides increasing the CDC Data Hub, and I'm super excited about what we've been able to achieve. And I'm super excited to have you guys here and with me. So on the data process improvements, this slide goes over the people side of things that we covered. And while I don't have as much quantitative measures of the tenfold improvement is the technical, provable performance improvements. But I have had epidemiologists come up to me and say, This new process is 1,000 times faster than the old process. And when I mathematically think about, it takes about 3 minutes to do the spreadsheet now, and it took about 3 days to do it before, I don't know that she's totally wrong. So a lot of, again, the reason that we may have spent more time in the technology talk on process improvements is because you might get more bang from your buck from those. But so what are the types of things that we went over? We went over how can we reduce hard coding in our code. We've gotten rid of the global reference. We've introduced global reference data standards. And we've reduced copy pasting in SQL. I also want to point out on the Power BI side, we've made dramatic reductions. So if you're putting 50 buttons on a Power BI report and you can put 5 tabs, not only is it that much faster for the developer, it actually responds that much faster. So we've made dramatic simplifications in the technology stack as well in Power BI, and also the amount of calculations that are done in the front end. The lines of DAX code has been totally dwarfed by Databricks routines now. And the net result is that we've been able to make our technology perform provably 10 times faster. And the reports, this is made, before we were at an impasse. You couldn't scale. Not only does it perform 10 times, these differences in performance would only grow as the number of columns and obstacles grew. So we've got a platform for the future now. And oops, minor connector went away. All right, scary. So thank you guys. So again, we've reduced the file size, we've reduced the application complexity, and we've also made it, the net result is that the thing's faster to load. But it also is a huge visual user interface experience because when it's that much, if you guys have seen a chart crawl versus a chart that's flows, it's a much better user experience. So what did we go over today? We went over dashboard drifters, not being able to find dashboards. We went over my personal death by docs experience, where the documentation is too big. We went over the vague vortex experience, challenge. We went over the molasses matrix when the report's too slow. We went over the phantom facts problem, where project managers have reports that aren't substantiated necessarily by the facts we would like to see. We have the pancake stack problem where the data table's too wide. We have the conversion chaos problem where there's not consistent universal adapters to convert data. We went over the opaque oracle where we don't have defined quality expectations and we don't necessarily have the synthetic data, or if we have it, we're not sharing it with everybody like you. And we have the metadata mystery problem, which is where we don't catalog our analytical products at the metric and dimension level. And we have the reinvention rocket, where we do the same idea steps over and over like the idea is new. And it's really a lot of the same things that can be used. So that pretty much wraps it up, guys. So those are the key takeaways are that there's the process modernization and the technology modernization and the RSV dashboard. I did want to say that there's so much more. What you've seen is admittedly descriptive statistics. And we can do predictive statistics and we can do prescriptive statistics. But you can have the best generative AI in the world. If you don't store these things in a way that's meaningful and useful, then you really lose a lot of its value, because your leadership doesn't need an interactive session like with the chat GPT when it comes to reporting the overall annual report. That needs another level of diligence, and that's the kind of diligence I've tried to show you guys today. So that concludes our presentation, and I have some other slides here, or we can do questions if you guys have some questions. I'm not sure how we're doing for time.